Hello everybody, so today we're going to be doing a few questions from motion, forces and energy. So let's go. First question, another person pushes a shopping trolley with the force of 40 newtons. The shopping trolley moves at a constant speed along a horizontal path. Calculate the work done by the 40 newton force to move the shopping trolley a distance of 50 meters. So work done formula is force multiplied by distance. So we can substitute 40 multiplied by 50 equals to, which is equal to 2000 joules. The work done on the shopping trolley as it starts moving is transferred into other energy stores. State two such energy stores. So one is kinetic because it is moving, and the second one is thermal due to the friction. Fig 4.1 shows the energy transfers in a lamp. State the value of the wasted output energy. So we just subtract the total input minus the useful input, which is equal to 12. So the wasted output is 12 joules. The energy that is increased is transferred into another energy store. State the energy store that is increased by the wasted energy. So it is a lamp. A lamp gives light, its main purpose, but as the light it also heats up, so it's thermal. A 15-watt lamp is switched on for 5 minutes. Calculate the electrical work done in the lamp circuit during this time. So first we know the power formula. It is equal to, power is equal to energy divided by time. And in this case it is 15 is equal to dash divided by x divided by 5, and we need to use it in seconds. So 5 multiplied by 60, it is 300 seconds. So divided by 300 seconds is equal to 15. So now we can rearrange this as, so 15 is equal to, so x is equal to power multiplied by time. So x is equal to 15 multiplied by 300. X is equal to, we can use calculators, multiplied by 300, 4,500. So our answer is 4,500. The lamp uses electrical energy that is generated by a wind tube. Fig 4.2 shows a wind turbine blades. Describe 3 energy transfers that take place when energy from the sun causes electrical energy to be generated by the wind turbine. So first it can be the sun's energy, which is thermal energy, into the kinetic energy of the wind, into the kinetic energy transfers to the turbine blades, which transfers to the kinetic energy transfers to the turbine, so the turbine spin, and the turbine spinning causes transfers to the kinetic energy of the generator, and then the generator transfers the kinetic energy into electrical energy. So it can just be electrical energy. The car is lifted vertically 0.78 meters onto the recovery vehicle as shown in figure 3.3. The weight of the car is 14,000 newtons. Calculate the minimum work done on the car in lifting it onto the recovery vehicle with the ground. Include the unit. So work done formula is force multiplied by distance. And over here, our force is 14,000 newtons multiplied the distance of 0.78. So work done is equal to, multiplied by 0.78 is equal to, this is our answer, 1000. No, it is 14,000 divided by 0.78 is equal to, it's equal to 14,000 multiplied 0.78, it is 10,920, and we can just round it up to 11,000. So the work done is 11,000 and the unit is joules. Energy stored in the water behind a hydroelectric dam is an example of renewable energy source. State what is meant by a renewable energy source. It is continuously replenished, which means it never runs out, and it is always renewed. There's always more. So continuously replenished. State the name of one other renewable energy source. It can be solar energy. Electrical power is generated from the sun energy stored in nuclear fuels. Figure 4.1 shows an energy flow diagram for transferring energy from the nuclear store. Using the information in Fig 4.1, calculate the percentage of energy wasted to thermal and kinetic energy stores. So, kinetic energy stores. So thermal and kinetic energy. So we can just add this. 50 plus 15 is 65%. Transferred as electric working is, so 100 minus 65, it is 35%. Electrical power is also generated from the water behind hydroelectric dams. State 2 disadvantages of generating electricity from the water behind hydroelectric dams compared with using energy stored in nuclear fuels. Ignore cost of construction and maintenance. So one can be, it depends on rainfall, because we need water, so it depends on rainfall or depends on weather. And the second one can be that it can disrupt habitats because there's just a bunch of water, so it disrupts habitats.